Hello, AGPS 170 students. In this video, I'm going to teach you how to estimate the quantity-dependent demand equation. This equation is, in terms of the equation format, is this. So on the left-hand side, we have a Q, that is quantity, and that is our dependent variable. And on the right hand side, I have my function, and my G is my function. In my parentheses, I have included 5 independent variables. And my first independent variable here is my P, that is my P self. So for my case, I am estimating the quantity dependent demand equation for chicken. So on my left hand side, I have my per capita consumption of chicken, and that's my demand. That's on my left hand side. So on my right hand side, my first variable is the real price of chicken. So this P is the real price of chicken. My second variable is the real price of my first substitute. In my case, that's pork. So I have the real price of pork. Second substitute is turkey. So I have the real price of turkey. Third substitute is beef, so I have the real price of beef. So, and the last variable is Y, so that is always the per capita average real income. So that's PC income. So you can find out on my left hand side, I should have one column, and that's the per capita consumption of major commodity. I have one column, and on the right hand side, I should have one column, 2, 3, 4, 5 columns for different variables. So that's how I should arrange the sequence of the columns in my Excel estimation. First column should be real price, followed by, first column should be real per capita consumption, and then I should, on the right of this per capita consumption column, I should have my per capita, I should have my real price of chicken, real price of first substitute, second, third, and the real income. So that's the equation. So if you look at the statistical models, it should look like this. So on the left-hand side, I have my per capita consumption of major commodity. I have an intercept, which is called alpha 0. I have my alpha 1, which is the to be estimated first coefficient, times my real price of my major commodity, plus my to be estimated coefficient for my the real price of my first substitute. So I use this coefficient times the real price of my first substitute, plus the to be estimated coefficient times its real price of my second substitute, and the to be estimated fourth coefficient times its real price of my third commodity, times the coefficient times the real income, per capita real income, plus an UT. UT is an error term. So that's a stochastic error terms. So that's the statistical model format that we are going to estimate. Okay, so that's the background of this quantity dependent demand equation. And let's open our Excel and see how we estimate this equation using regression in Excel. So we're going to first of all go to data. We're going to click our old friend, data analysis. We're going to choose regression, click OK. So in my input Y range, I am going to pick my per capita consumption of chicken. This is my Q on the left hand side of the equation. And then my X range, I am going to include my real price of chicken, real price of pork, real price of turkey, and real price of beef. So now I have included the real price of my major and my substitutable products. I'm also going to include the real per capita income as my independent variables or as my explanatory variables. Independent variable is also called explanatory variables. So I'm going to include this, and I'm going to click my output range. I will just randomly pick a blank cell. I'm going to click OK. Okay. So this is the output. If you look at the R-square, I have a very high R-square of 0.98. Like I mentioned, if the R-square is above 80%, this is my case, above 80%, I do not need to go down to other statistics. I am confident that my estimation is valid. Just a quick review. In the case if the R-square is below 80%, we need to go check the F value to find out if it is above 5 or not. So 5 is our rough criteria. So we'll use 5 as a criteria for F statistics. And if it is below 5, in my case it's not true. My number is a lot bigger than 5. So if it is below 5, I'm going to check my significance of F. So we have a very, very small significance of F. In my case, I can confidently move to the next table. That's my estimated coefficient table to check the significance level for each of the included variable. So I'm going to check the T and P value. Let me just highlight these two columns. Okay. So my first included variable is the real price of chicken. So for the real price of chicken, I have a big T stat. The absolute value is above 2. I have a very small p value, which is much smaller than 0.1 or 10%. So I am confident this real price of chicken has a significant impact on the change of my quantity demand of chicken or on my per capita consumption of chicken. So let's look at the real price of pork. We have a very small t value and a high p value, which means this real price of pork is not significant. This real price of turkey, when we take the absolute value, is above 2. And the p value is less than 10%. So this real price of turkey has a significant impact on the real per capita demand of chicken in this case. And let's check the real price of beef. We have a very small t and a big p value, so this variable is not significant. Let's check our real per capita income. We have a very big t value and a quite small p value. So in this case, we are sure that our real price of income has a statistically significant impact on the per capita demand of chicken in this case. So I've chosen 3 variables, and these 3 variables are statistically significant in terms of affecting the demand, or in our case, the per capita consumption of chicken. We use the per capita consumption of chicken to render the demand of chicken. So in this case, we have 3 variables. So let's look at each of them. So as I mentioned, on the left-hand side, we have the per capita consumption of chicken. On the right-hand side, the first variable we have is the real price of chicken, and we found a significant negative impact of the real price of chicken on the demand of chicken. So again, we figured out a negative sloping demand curve. So in this case, when the real price of chicken goes up, the per capita consumption of chicken would go down. So that's this negative sign means. So we also have a very big coefficient of about 10.37. That means when the real price of chicken goes up by $1, in this case, because my real price of chicken, I was using dollar as my unit. So when this real price of chicken go up by 1 unit, which is $1 in this case, the per capita demand of chicken would go down by 10.36 pound. So because my dependent variable is in the unit of pound, so it's very clear when price go up by $1, the quantity demand would drop by 10.37, about 10.37 pound. So that's how you interpret the sign of this coefficient and also the magnitude of this coefficient. So let's look at our second estimate. That's the real price of turkey. So first of all, I have a negative sign for this coefficient. You guys do remember when the sign is negative, we find out the two products are complementary. When the sign in here, if the sign is positive, we are sure the two products are substitutables. So in this case, we find a negative sign and it is statistically significant. That means we find out chicken and turkey, they are used as two important substitutables, which does not make sense. So we should not include the real price of turkey in this case, because the sign here we find out does not make sense. This negative sign means two complementary product. So we want this sign to be positive to show the turkey and chicken are substitutables, but in this case it is not true. We found them to be two complementary product, so we need to take off the real price of turkey in our next estimation because it does not make economic sense. Okay, now let's look at the real per capita income variable. This variable, number one, it has a positive coefficient, which does make sense because when per capita income goes up, people's demand for food product would go down, but the magnitude of change would be very small. So we first of all we find out when income goes up, it will have a positive impact on the demand of chicken. So we have a positive sign in here. Second, this estimates or coefficients is very small. So that means when income goes up, the per capita consumption of chicken would go up a little bit, but the magnitude is not very big. So that's my first estimation for my quantity dependent equation. So I'm going to stop here. In my next video, I'm going to show you how to run the cleaned or finalized equation for my quantity dependent keeper equation. Thank you.